All right, at a minimum wage of $15 an hour, that might be important, an 18-year-old working a 40-hour week will make $2,760 a month. Suppose they decide to deposit $100 a month into an IRA with an APR of 6% until they retire at 70%. Looking through this, I'm realizing that some of this doesn't matter. Like the $15 an hour, that doesn't matter. And the 40-hour week doesn't matter. But the that doesn't even matter because it's not relevant to what we're solving. The only things that are going to matter are that 100 a month, that 60%, the 70, and the 18. So, how much money will be accumulated by this time? This is a really interesting question because what we're doing is we're not doing that like a compound interest. It's not just growing like that. We're actually depositing $100 a month. So remember, the early stuff accumulates more compound interest. The later stuff gets less. So I think this is savings plan, right? Savings plan formula. And writing that out, let's see. It's A is equal to. I've been doing payment. And then it's 1 plus R over N, because we've got the compound interest. And then we can do the NY, and then it's a minus 1, and we've got to be careful because that's all grouped together. And then on the bottom, it's an R over N. Okay, so how much money will be accumulated by this time? Okay, so A is going to be the thing that we know, the amount of money over time. The payment is going to be $100 a month. The R is going to be 0.06%. That's the APR. The N will be, let's see, it's monthly, right? So that's 12 times per year. The Y is going to be, that's a little bit trickier. So 70 minus 18. I get that as 52. You might want to double check me on that. And let's see, that's covered, that, and that's just twice. Okay, so this is going to be, A is equal to, I'm going to put this out in front, 100 times 1 plus 0.06 over 12, all raised to the 12 times 52, because it's happening for 52 years, minus 1. And on the bottom, we get 0.06 divided by 12. Okay, you're going to want to be careful when you do this, putting it into the calculator. I ended up getting something that looks like, let's see, 420.420 0.14, and I think it's a 1 after that, so that should be correct, rounded to the nearest cent. Okay, so calculate the total of the deposits over time. Well, the total is just going to be the amount of deposits, right, over the entire period. That's going to be equal to, it's $100 a month times 12 times a year, and then you do that for 52 years. So that'll be, calculate that out, that's 624, oh, no, there's not a 5 there, 62400, and that's the total amount. Is that what we needed to do? Yes, and then write a quantitative sentence relating it. Well, I don't know. We could do something like, you earned this much over the time, and compared to that, 2,400. There we go. That's about what, like 6.88ish. So writing out the full sentence, the amount in the account is 6.88 times the amount deposited. All right, I got to say, that's a pretty good investment over time. Good luck getting that 6% right now. It's much closer to 1 or 2% if you're lucky, but still, definitely worth saving some money.